Hi, boys and girls. So this is going to be the Chapter 7 assessment practice. So we're going to have this split up into several different parts. So this will just be part 1. So we're going to start right here with number 1. It says, Courtney has 36 photos to arrange on a gallery wall. How many arrays can Courtney make with the 36 photos? List all of the possible arrays. Now, we don't have to actually draw a picture of the array. We can just use a multiplication equation to list out all of the different arrays, because that's all an array is, right? It's just a different representation of a multiplication problem. So let's list out all of the arrays that we know we can come up with for 36. So what's one of the first ones? 1 times 36. What's another one?
2 times 18.
You're correct, but let's not skip ahead. Let's look at this again. We can do 1 by 36, or we could also do what?
36
A 36 by 1. And then I heard somebody say we could do a 2 by 18, or we could do a what?
18 by 2.
An 18 by 2. Are there any other?
Yes.
Good gracious. Are there any other arrays that you can think of?
6 and 6.
Yep, you could, but let's keep going in order. So we've listed 1s, we've listed 2s. What about a 3?
3 and 12.
We could do a 3 by 12. What about
4 and 9.
we could do a 12 by 3.
4 and 9.
I heard somebody say a 4 by 9.
6 by 6.
What about a 9 by 4?
6.
A 9 by 4. Could we do a 5? No, because it doesn't end in a 0 or 5, so it's not divisible by 5. But we did say a 6 by 6. Are there any other possible arrays that we could come up with for 36?
No.
I don't think so either. So how many total arrays can she make?
6. No.
1, 2, 3, 4, 5, 6, 7, 8, 9. So how many total arrays can she make? 9. So she can make 9 total arrays. Okay? So I'm going to move this so we can see our final answer.
I only have 5 because I just did the 2 charts.
So this is part A. So how many arrays can she make? 9. Now, it asks us in part B, what are the, or how many factors are there for 36? Write them. What do you notice about the number of factors and the number of arrays Courtney can make? So before we get too far into what do we notice, let's list out the factors of 36. Okay, so I'm going to go ahead and drag that over here to my chart so we can see it. And I know that we like to make a T-chart just because it's easier to read. All right, so let me move my word or my text box. And let's get started. What's the first factor pair for 36? We always start with 1 and itself. What's the next factor pair?
2 and 18.
Yep. 2 and 18. What's the next factor pair?
3 and 12.
Uh-oh. 3 and 12. What's another factor pair? 4 and 9. What's another factor pair?
6 and 6.
6 and 6. Okay, so these are all of the factors of 36, right? I wish I could like organize this better, but we're doing the best we can here. All right, so here are our factors. So what do you notice about the number of factors of 36 and the number of arrays that Courtney can make? What do you notice? How many total arrays can she make?
9.
9 total arrays. How many total factors are there?
5.
Well, those are factor pairs, but individual factors, how many are there? There are 9 individual factors. So there are 9 arrays and 9 factors, right? So we could say that the number of factors is the same as the number of arrays. So that would be what we noticed was the same.
Do we write that down?
Yeah, that's part of the question. So what do you notice? That it's the same, right? All right, so let's look at part C now. It says write all the factor pairs for 36. Is 36 prime or composite? Now, we've already listed out the factor pairs in part B, so I'm not going to list those again, right? But we can answer this second part. Is 36 prime or composite? So what is it?
Composite.
It is a composite number. So we can say 36 is composite. And then can someone tell me why is 36 a composite number? Kelsey, tell me.
It has more than 2 factors.
Yeah, we know that 36 is composite because it has more than 2 factors. Good. So we do not have to rewrite the factor pairs, but we do need to list that it's because it is composite because it has more than 2 factors. Okay, so now let's look at number 2. It says determine whether the numbers in each list are factors or multiples of 16. So we have to remember that factors are 2 numbers that are multiplied together to equal a product. Okay, so when we're looking at these, we need to ask ourselves, can we multiply these numbers times something to equal 16? Okay, so let's start here in our first little box. We have 16 and 48. Can you multiply 16 times anything to get to 16?
No. Yes. Right. 1.
1, yes. So we can technically multiply 16 times 1.
I thought you were
But what about 48? Can you multiply 48 times anything to get to 16? Yeah, you would end up having to divide there. So that we know that these two, this pair cannot be a factor, right? It's a multiple. So we could if we count by 16s, we would eventually get to 48, right? So we know that, oh, come on, Miss Barton. We know that 16 and 48 are going to be multiples of 16. Okay? Let's look at this next little set right here. We have 1, 2, and 4. Can we multiply 1 times something to get to 16?
16.
Yes, we can multiply 1 times 16 to get to 16. What about 2? Can you multiply 2 times anything to get to 16? 8, yes. What about 4?
Yes. 4 times 4.
4 times 4, correct. So we know that 1, 2, and 4 are what? Factors or multiples? Factors of 16. Good. Now, let's look at this next set right here. We have 8 and 16. Can we multiply 8 by something to get to 16?
Yes.
Yes, we can multiply by 2. What about 16?
No. Wait. 1.
Yeah, we can multiply 16 times 1 to get to 16. So that means that 8 and 16 are what? They are factors of 16. Good.
I thought you meant like 16 to get to 8.
No, we were just trying to get to 16. All right, let's look at this last set of numbers right here. We have 32 and 64. Can you multiply 32 times anything to get to 16? No. What about 64? No. So we know that these two numbers must be multiples of 16. Okay, any questions about this one? Wonderful. Let's move on to number 3. It says, which statement is true. Now, when we get to a question like this, it's very important that we read through every single one to make sure that we understand what it's asking us. Okay? So let's start with letter A. It says the only factors of 3 are 3 and 1. Therefore, 3 is prime. What does prime mean?
Only 2 factors.
That's right. A prime number means that it only has 2 factors, 1 and itself. So is this a true statement? Yeah, it is a true statement, but I don't want to just stop here. I want to go and double check and make sure the rest of them are false before I commit to just my only answer, right? So let's look at letter B. It says the only factors of 4 are 4 and 1, therefore 4 is prime. But is that a true statement?
No.
What's another factor pair of 4? 2 and 2, exactly. So that can't be true. Look at letter C. It says the only factors of 5 are 5 and 1, therefore 5 is composite. This is not a completely true statement. Yes, it is true that the only factors of 5 are 5 and 1, but would that make it a composite number? No, that's right. It would make it a prime number. So let's look at letter D. The only factors of 8 are 8 and 1, therefore 8 is composite. Is that a true statement? No, there are more than just the 2 factors, 8 and 1 for 8. That's right. You can do 2 and 4. Yes, 4 and 2. That's right. So therefore, the only statement that is true is letter A. The only factors of 3 are 3 and 1. Therefore, 3 is a prime number. And I believe that is going to be the end of this particular video. I will get started on a part 2 right now. So be looking for that, and I'll see you in just a second.
Bye.